Hi guys, welcome to day 3 of the journey video. Um, we're going to start our third challenge. Ooh, this one is first hard one that we've received. Um, okay, so problem 149, max points on a line. Given an array of points where the point I is another array representing a point on the xy plane, return the maximum number of points that lie in the same straight line. Okay, so it's a 2D array where the outermost dimension is just the collection of points, and the innermost is points. Um, so an example of this points array is 1, 1, 2, 2, 3, 3. So they all have the same slope. They all have the same x-intersect. The output is 3. Okay, perfect. Another example, 1, 1, 3, 2, 5, 3. So those actually form a line similar to this one, except the slope is 1/2. But then there's also this other line, 4, 1, 2, 3, and 1, 4. And those form another line. And the output happens to be 4. Okay, so this makes sense to me. I'm sure that from high school everyone remembers this formula. Plus b. These are two constants, one indicating the slope, one indicating the x-intersect. My idea is that if I was to find all the different slopes between each line and make some sort of dictionary where those two constants indicate the key and the value is the number of occurrences of points on that line, I could find the uh, line with the most amount of points. That should take time complexity of O n squared because I'm looking for all different pairs of points. That seems like the most naive and the brute force solution. The other sort of solution. Well, I don't really know. Maybe this could be a sort of graph problem where um, each point is a node and the edge between those two nodes is this value or this condition, or sorry, this value of mb, the slope and the x-intersect, but that would still require us to calculate all different pairs. So that would still be on squared. So I can't really save time there. I'm wondering if I can save time by somehow knowing which what which slopes are the most likely, which ones I should start off at, because I'm thinking that if I find a slope that is covering more than 50% of all the dots, then there's no point of me looking any further, because if I find that line that's more than 50%, then I automatically can say that that is the most populated line. Okay, I don't know about that. For now, let's start with the brute force solution. Seems like the most appropriate. I'm also thinking that why do I need to calculate the x-intersect if I'm solely caring about the relationship between 2 points? So let me talk on this a little bit more. If if I'm looking at this line at this point here, and this being my starting point, this is being my for I in range from 0 to n minus 2, and for j in range I plus 1 when actually this would be minus 1. This would just be n. If this is pointing, if I is pointing at this line, at this point, and j is looking through all the other ones, why do I need to keep track of the x-intersect? Why do I need to keep track of this b number? Because if I find this 1, 2 lines here, or dots here, and say that this is my line, when I change to another point of truth, I'm not going to consider, I'm going to reset so for each point, essentially, I'm going to find the maximum number of points that exist for some slope. Something like this. Max number of points maximum number of on line. It's just going to be a dictionary. Max points on line. It's going to be an empty dictionary. And then there's this function that calculates slopes very well, called arctan2 by math. It's going to be something like max points maximum points 0 max points is going to be max points the key is the math RA tan 2, that's what I was talking about, and the two values are points I, this is the x, minus points j 0, this is my x value, and my y value is going to be points I 1 minus points j 1. So once I find this, I also, now that I'm now between different i's, between different points of truth, I have to essentially figure out if some other point that I'm currently looking at beats the maximum populated I'm just going to call it max line population. If my if some max points on the line beat my population, and that's going to be this, and max in the values Now also the values, it doesn't include the point itself, so I'm actually going to be putting that here to make this make more sense of it. I should probably initiate this with all ones, but that's already. Let's see, and then I should just return the maximum. I should just be able to return this and call it a day. Let me look through this quick. Let me see if any constraints actually prevent this from being run successfully. So also it could be equal to 1. That's a problem because if it's equal to 1, then this whole setup will break, because I'm never going to go in here and wait, will I never be able to? Yeah, I'll never go in here, and it's just going to return 1. Can I just do this? That should work. Let's see, if I have 2 points, then the length is going to be equal to 2. So yeah, I'm going to calculate the max, which is 1, plus the max plus 1. This, yeah, I'm pretty sure this should work. Key error. Max points. Default dict int. Okay, so what I did here was I chose a specific collection where the key is going to be of type int number, output 1, expected 2. So why output 1? Am I never resetting this? Math A10 collection. So it seems to me like I'm never resetting this. If I run this, yeah, I'm never actually going into the loop. So, let's check this one more time. So the range for the truth point is going to be from 0 to 2. From 0 to 2, essentially. So 2. So it's going to go through 1, 0 and 1, 0 and 1. I know this is kind of embarrassing, but I like printing out does Python do this? How does Python do formatted strings? Okay, same thing for J, 0, 1, 2, 1, 2. 0, 1, 2, 1, 2. Okay, that's all good. Let's see now. Maybe I'm not counting the arctans correctly. So I do this sort of debugging when I'm one, two. So there's 3 comparisons, which is fine. I did just notice that I'm not actually setting anything. One, but no. Expected output still 3 because I'm not resetting. I'm not comparing it. And expected is now 4. Great. So now I'm overshooting it. Why am I overshooting it? So I'm overshooting it because I'm comparing it 3 times, but I am also resetting it. Let me check. Yeah, I'm resetting it here. So the first time the first time I look through the point, it goes, oh, wait, the first one worked. It's the second one that didn't work. Expected 4, but only got 3. Oof. 1, output 3, so 4. This is this second one that I'm doing here. So first comparison is 1/2. Let me look at the for point 1, point I, point 0, point 1, the value should be the value should be 2 here. Well, no. Yeah, sorry. That's how I do it. I just remembered. One, 2, 1, 1. Okay. So I actually don't know what these are, but 2 points here, 1 point here, 1 here, and 1 here. For the 0th, 1, 2, 3, 4, 5. Okay, no, this makes total sense. 1, 2, 3, 4, 5. This one, which is the second one, should have 1, 2. Oh, for point 1 has the values of 1, 1, and 2. One, two, three, four. 1, 2, 3, 4, 5. This one has 1, 2, 3, 4. 1, 2, 3. Yeah, no, something is definitely wrong. Something is going on with maybe this here. Why is why is it not recording all of the it's looping through all the numbers, but for some reason it's not finding the sorry, 1 second, one more time. 1, 4, 2, 3. So the first one should have 2 as the max. The second one should have 3, 2, should also have 2, which it does. The third one should also have 2, but it only has it only has 1. And the third and the fourth one this has, am I looking at the right points? Why am I only seeing 4 points? I'm only seeing 4 points. I'm only seeing 4 points because of the way that I've set up this loop. I've set up this loop to only check for all the I know what I did wrong, basically. This is how it's going to work. I, J, I, also. And if I does not equal J, then do the following. That was my mistake. So, well, it's an empty sequence. Max with an empty sequence because it's a one pointer. So if n is equal to 1, return 1. That should be fine. Let's do 2. Sweet. Okay, so beats. Okay, so actually I was pleasantly surprised. I was under the impression that this was not the fastest solution. This seems like this is a very good solution. I wouldn't say that was a hard problem. To talk briefly about what's going on, and I don't know. My feelings about this is that um, I got way too scared probably off the first time. I thought that this was going to be very hard. The approach seems kind of trivial, kind of what I came off right off the bat, that we will have to check all the pairs, not just uh, we will have to check all the pairs. I just thought of a way of improving this potentially. A way to improve this, I think, would be to remove this from here and to actually just count the total number of let's do that really quickly. And then I'll try to explain what I'm talking about. This is a default dict, and then we're going to go back to my original setup, which is 0, 1, I, n, and it will never equal, and we will, so if I'm never looking at two things, if I'm never looking at two pairs more than once, if I'm never looking at two pairs more than once. Oh, here I run into the problem of a pair having the same of a pair having the same um x inter or different x intersect but having the same slope. So actually this is not going to work. My idea was that in the approach before, I was doing a pure O(n) squared approach where I would check all pair against each other. But what I was just about to do is I forget what this is, but do you see how it's always starts at I and it never, this is still O(n) squared, but I'm not actually doing redundant checks. I'm only checking for the pairs between points, not because in the previous setup, I would be checking this point against this point and this point against this point when this is the point of truth. But when this becomes the point of truth, I'm doing a redundant check against this point. And so a way around that is to kind of once I've done one, check with this one, check with this one, this one, this one, this one, I exclude this from the checks completely. And now my point of truth is this. And since I've excluded this point, I'm going 1, 2, 3, 4, and then 1, 2, 3, and then 1, 2, and then I don't need to check this anymore because I've checked all the pairs. The problem there is the pairs, this setup here, the previous setup, actually allows me um, to remove having the check for the x-intersect. Yeah, I guess this solution is better, or at least quicker to implement. Probably on my own time, I would go ahead and try to um, implement it faster, but if this works, works. All right, thank you guys. Thank you for watching. Tune in tomorrow. Thank you.